Got home from the football game. Sorry, boys. Lost. Played hard, though. Played hard. And then I took a nap. Now I'm drinking, oh, you guessed it, Brugger's coffee. Why? Because I'm really tired. My wife says my eyes look all red and crazy tired. Okay, whatever. We're going to get working. All right, let's see if we can remember a few things. First of all, let's look at all these things. Let's see, how many of these are circles? We only got one that's a circle. That's easy. Let's take care of that one right away. This is C. Circle. Right there. Oh. Maybe I shouldn't be working. I just somehow got off by a line. I mean, I saw it. I was there. And then I'm like, okay, C. That's the circle. The two squares. You got the squares and the squares. All right. So we got an absolute value here that's coming down and it's wide. I'm sorry, coming down and it's steep. That would be F right here. Coming down it's steep. So that would be F. We've got another absolute value that's wider. That's D. All right. Then we got this is a square root that just moved up 3 units. So that would be A. And then this is a cube root. And there's only one cube root on here. So this one has to be E. And let's see, this one moved to the right 3, down 5, reflected in the y-axis, but we're only out of letters, so that's got to be B. All right, there we go. Kind of went through those things. Now I got to find my mouse pointer. We're at Mr. Key, by the way, helping you out. All right, so let's see. F of x equals x squared. This is the quadratic. This would be 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. Remember that 0, 1, 4, 9, that 1, 4, 9 I was telling you about? Well, look, it's symmetry. That's why it's the axis of symmetry. In this case, the axis of symmetry would be x equals 0. Because this is 1, this is 4, and this is 9. They're always going to be like that. Plotting at the point here, 0, 0, 1's to the right, 4's to the right and left, and 9's to the right and left. There we go. 1, 4, 9. Boom. There's the pattern. 1, 4, 9. Now this is the parent function. This is the parent function of a quadratic. Okay? We know this is the parent function of the quadratic. It's very important that we understand about this vertex. In this case, my vertex is 0, 0. Just like with the absolute value, just like with the square root, just like with the cube root, over and over and over again. And now we're going to transform that thing. What is the shape of f of x? It is a parabola. What is the domain of f of x? It goes from negative infinity to positive infinity. The range goes from 0 to positive infinity. The vertex is at the origin. Is the vertex a minimum or a maximum? For the regular, it's a minimum. Making the parabola concave up or concave down. We haven't talked about concavity. I'm not sure why it's in here. But anyway, it's concave up. All right? Concavity means where is the U facing? Which way is it facing? That's where it's concave up. All right. Over what intervals is f of x increasing? So it increases on that root from 0 to infinity, and on the decreasing on the other half of the parabola. See, it's increasing on that half, and then decreasing on that half. So from negative infinity up until 0, it's decreasing. And the axis of symmetry in this case is x equals 0. All right, so what we're going to do is we're going to take a look at these quadratic functions, and we're going to look to see what the transformation was. So in this case, we took f of x and we went down 3. So it goes down 3. So it's a translation. Translation down 3. And the new vertex, instead of it being 0, 0, since we're going down, that's going to change the y value. It's 0, negative 3. This one is a dilation. It is a dilation. Because it has the 1/4 in there, that means it's going to be wider. But it didn't move left and it didn't move right. So the vertex will never change unless we're adding or subtracting something. So in this case, my vertex is still the origin. This one is a reflection. reflection. Why can I not write, guys? You know why? I need a new computer. This is a reflection. Okay, so because I didn't add or subtract anything, of course, the origin is still the vertex. Now, when I add on the inside, it's the same as when you add on the inside with the absolute values or subtract. This is a translation, and it is right 4. Remember, on the inside, it's backwards. So our vertex that was at the 0, 0, since it's moving to the right 4, this is going to change to 4, but we didn't go up or down, so it's still 0. So in this one, we got all kinds of crazy stuff going. This is going to move it to the left 2, so we got a translation. We got 2 translations. We're going left 2, 2. We're going a translation up 4. It is a dilation of 3, which means it's going to be much steeper. And we also have a reflection. So in this case, the vertex is going to be -2, +4. I'm not going to change that. That's just going to be the vertex. It's just going to start there and come down. All right. So this is vertex form of a parabola. The degree is 2. This is the degree. It is the exponent. A is positive. Oh, and it also means it's going to be a parabola, right? Obviously. I think we're going to talk about that later. If A is positive, it's going up. If A is negative, it's going down. If the absolute value of A is greater than 1, which means we have a number that's bigger than 1, positively, or a number that's smaller than -1 negatively, like -2, -3, -4, that just makes it, why did I do this? That just makes it steeper, makes it really steep. But if the number is between 0 and 1, or between 0 and -1, that makes it a wider one, just like with before. When we're adding or subtracting on the x, this is a translation right. This is a translation left. When I add at the end, that's a translation up. And when I subtract at the end, this is a translation down. This is all nothing new. But in order to look at this, we need to look at it in vertex form. See, this in here moves it left or right. This or here is going to move it up or down. This is going to decide whether or not it's wide or steep or normal. And if we've got a negative out front, that will mean it's got a reflection. So we need to be able to learn how to transform from standard form into vertex form, or from vertex form to standard form. And it's not that bad. So if I graph this thing, it looks like this, where the vertex appears to be at -1, -6, or the axis of symmetry, but x equals -1, and this is a minimum. But I want to be able to teach you how, without graphing it, how to get this in vertex form. So what we're going to do is take a look at this piece right here. And we're going to do a modified completing the square on this. So what we do is we say, okay, x plus 2x plus square minus 5. That's our new function. I don't know why I have it equal to 0. I shouldn't have it equal to 0. That's silly. I got to get rid of that. So I got to figure out what to do in here now. This is from a long time ago. Completing the square, we take half of this and square it. So we're going to divide by 2. and then square it. And that's why I put the square there. So half of 2 is 1. So my new quadratic is y equals, this should be x squared. Boy, I'm really tired. X squared plus 2x plus 1 minus 5. But I can't just add 1 here. I also have to, how do I want to show this to you? That's why I put the 0 in there. Let me go back. Let me go show you something. This is why I put the 0 in there. Now I remember, because I want to show you a different way. So what we're going to do is, eventually I want you to skip this. So I got to go back and remember, oh yeah, I want you to skip this first part eventually. But right now we're going to let's just look at it like this. X squared plus 2x minus 5 equals 0. If you remember back from algebra, completing the square is we move this constant over and rewrite it with 2 squares. Plus square here equals 5 plus square here. Correct? So then that we take half the middle and square it, we get 1, but we got to add it to this side as well. So on the left side, I get x squared. Oh, man. So what I'm going to do is I'm going to factor the left side. This is why you do completing the square. And if you remember correctly, it's x plus whatever that half of was before you squared it. In this case, it's still 1. X plus 1 squared equals 6. Now what we're going to do is to finish this completing the square process, we're going to bring the 6 back to get it in vertex form. So x plus 1 squared minus 6 is equal to y. So this is the transformation from, or the manipulation from standard form to vertex form. And you'll notice then that the vertex is right here. -1, -6. Let's do that a couple more times. So the first thing we're going to do is rewrite this, set it equal to 0. Plus box equals 13 plus box. Now when I move that over to the right side, don't forget you got to change its sign. All these little things you got to keep track of so you don't make dumb mistakes. So what we're going to do is we're going to take half of this and square it. So half of this would be 4, squared would be 16. So I'm going to add 16 to both sides. Now, this in factored form is x plus 4 squared. Whatever that half is goes there. Is equal to 3. Now we bring the 3 back over and we write it as y equals x plus 4 squared minus 3. So in this case, my vertex would be -4, 3. Now I want to check that. I want to see if I'm right. Now I could graph it and just see if that's the right. I could graph this parabola and see if that is in fact a parabola. Or I could do it using algebra. And I'm going to use algebra. X is equal to -b over 2a. Remember, to find a vertex, you first find the axis of symmetry. So in this case, it's -8 over 2 times 1, which is -4. Ah, look. So far, so good. There's the x part. To find the y part, we plug it in. So -4 squared plus 8 times -4 plus 13. I'm hoping this turns out to be 3. This is 16 minus 32 plus 13. And when you add that all up, you get, oh, this should be -3 by the way. Well, so I'm glad I checked it. This is -3. And this is -3 as well, too. Don't forget, the x part comes out opposite sign, but the y part stays. So that should have been -3. So I'm actually kind of glad I checked it because I made a dumb mistake there. All right, here we go. Okay, let's tackle this problem. All right, with the -2 out front, it's done a little bit differently. It's a little bit different, a little bit crazier. So what we're going to do is we're going to take out that -2. And And we're only going to work on this piece of it. So I've taken out the -2. And what we're going to do is we're going to do this little completing the square trick just on this part right here. So x squared minus 4x plus square equals -2 plus square. And then we're going to take half the middle and square it. Half of is -2 and squared is 4. So we're going to put a 4 on both sides. So what I end up getting is x minus 2 squared, because that's this thing, factored, is equal to positive 2. And then when I bring it back, or bring that 2 back, I'm going to get x minus 2 squared minus 2, and then that equals 0, but we don't need to worry about this anymore. So this is this new middle piece, because remember, we got, in order to do completing the square with a number out front, we got to get rid of that number. So that's that thing right there. So let me grab another pen. And so what I'm going to do is I am going to have this -2 out front, and I replaced all of that with this thing right here. So it was x minus 2 squared minus 2. Well, then I got to redistribute it back. So I get -2 x minus 2 squared plus 4. And yes, that is right. Oh, my equation is y equals. So in this equation, we've got a reflection, we've got a dilation, we've got a translation right 2 and up 4. And I took the time to graph it. That's what it looks like. -2x. There's my vertex 2, 4, and it's coming down. You see how skinny it is. Okay, there that problem is. I don't know why this is up. So we're going to go down. Let's try this one. So this one's just an easier one. We got just x squared plus 5x plus square equals -2 plus square. Now I say easier, but not so much, because somebody's saying, wait a second, the middle term's odd. And in 9th grade, you probably were told, hey, if it's odd, don't do it by completing the square. But in this case, I would like to. So we're going to take half of this. Half of this is 2.5, or 5/2. And if I square it, I get 25 over 4. So we're going to add 25 over 4 to both sides. Now, I am going to convert these probably to decimals. Well, no, I'm not. So my vertex, or my equation is x plus 5 over 2 squared is equal to, now in order to add these together, I'm going to do -8 over 4 plus 25 over 4. And you could just do this on your calculator if you want to, -2 plus 25 over 4. And this would give me, what is this, -17 over 4. And I'll just add that back, so I get y equals x plus 5/2 squared plus 17 over 4. So my vertex in this case would be 5/2, comma, 17 over 4. For those of you who like decimals, it's 2.5, comma, 4.25. There it is. All right, moving on. I think we're going to circles. Oh, circles. So this is the standard form of the circle, or the center radius form of the circle. And we're going to go into general form. Now, general form is sort of a pain in the neck. What you're going to do is you're going to take each of these pieces and square them out. So what I get is, let me just do this part. I'll do it this way. X plus a, x minus h, x minus h. So you get x squared minus 2xh plus h squared. And when I do the y's, I'm going to get y minus k, y minus k. So that's y squared minus 2yk plus k squared. So all I did was double distribute that out and double distribute that out. So now I'm going to add those two together. So that's y squared, x squared plus y squared minus 2xh minus 2yk plus h squared plus k squared equals radius squared. Oh my gosh, that's a pain in the neck. Don't like the general form of the equation. The general form of the equation, let me scroll down here, is right here. It's normally it's going to be written a slightly different way, but basically all it is all that stuff just foiled out. And I'll show you how that works algebraically with real numbers, because you don't want to see this. This is craziness, crazy. So what I'm going to do is I'm going to write this circle in standard form first. So that's x plus 1 squared plus y minus 3 squared equals, now wait a second, be careful, I said a diameter of 8, which means it's a radius of 4, so I put a 16 over here. So what I'm going to do is, if I want to write this in general form, I want to have everything on the right side. I want to have everything on the right side. Sorry about that. I was just thinking I had something wrong down there. And so in order to do that, I'm going to double distribute it out. Let me change the colors. I'll go to black. I'm feeling black for some reason. So we're going to double distribute this x plus 1 squared. So this is a little bit more of a concrete example of how to get to that general form, which is really x plus 1 times x plus 1 plus y minus 3 times y minus 3 equals 16. Now eventually we're going to bring that 16 over. Now if I double distribute this out, it's x squared plus x plus x plus 1. I'll show you all those steps if you want to see them. Plus y squared minus 3y plus 9 equals 16. All right, so my final step is just to clean everything up and bring that 16 over. So I get x squared plus 2x. Now I'm not going to worry about that constant right now. Plus y squared minus 6y. Now let me go and highlight all the constants. So this is 1 and 9. That makes 10. But I'm going to bring this 16 over and I'm going to subtract 16. So 10 minus 16 is negative 6 is equal to 0. And that is the general form of the line. And you'll see it right here. Another general form of the line. So here's how we convert from the general form to the standard form. And what we're going to do is that completing the square trick, but we're going to have to do it twice, one for each squared term. And it's actually not as bad as you think. So let's get started on it. So we're going to do x squared plus, doggone it, x squared minus 4x plus square plus y squared plus 6y plus square is equal to negative 4, because we're going to bring the constant over, so that's what we normally have done. But do you notice there's 2 squares on the left? Because there's 2 squares on the left, we're going to put 2 squares on the right. Now, half the middle squared minus 2, we put a 4 here, and if I put a 4 there, I put a 4 over there. Half the middle plus 3, and I'm going to put a 9 there, that's squared. So if I put a 9 there, I got to put a 9 there. So all of this thing here factors to x minus 2 squared plus y plus 3 squared is equal to, these cancel, right? 9. So my center is 2, negative 3, and my radius is equal to 3. And if I had to graph it, that's what I could graph. Sweet. All right, let's keep going. We've got a couple examples more to do than that. We're going to do that a couple more times. So let's go. So what we're going to do is we're going to complete the square twice, put this thing in standard form or center radius form, and then we're going to tell you what the vertex in the center is, or vertex in the radius is. So it's x squared plus 2x plus box plus y squared minus 8y plus square or box is equal to negative 1, and then we're going to have 2 boxes because we got to do completing the square twice. Let me change colors so you can see this. Half of this is positive 1. Positive 1 squared is 1, and let me finish that. It's x plus 1 squared plus, oops. So half of this squared is negative 4. Negative 4 squared is 16. Oh, by the way, I should have put this positive 1 over here and this positive 16 over here. So this gives me y minus 4 squared is equal to 16. Again, these cancel. So my center is negative 1, positive 4, and my radius is 4. It's that easy, kids, that easy. I think we just have one more, and then I'm going to show you how to use the calculator to do some of this stuff. And I'm going to show you how to use the calculator to check your answers. Okay, so x squared minus 2x plus square plus y squared plus 4y plus square is equal to negative 1. Remember, this is coming over. Plus square plus square. I ran out of room. Change colors. Half of this is negative 1. Squared is 1. We'll put a 1 on both sides. Half of this is positive 2. Positive 2 squared is 4. We'll put a positive 4 over here. So this thing factors to x minus 1 squared plus y plus 2 squared is equal to, again, the 1's cancel. That doesn't always happen, but the 1's cancel in that case, and I get 4. So my center is 1 comma negative 2, and my radius is 4. Now the good news is graphing these on the TI Inspire is very, very, very simple. And let me take you through those steps. What I want to do is, instead of doing that last page, what I want to do is I want to check my work here. So what I'm going to do is I'm going to graph this thing both ways. I'm going to graph it this way using my TI Inspire, and I'm going to graph it this way using my TI Inspire. And if they overlay on top of each other, I know I graphed it correctly. So let me bring my Inspire up, close out of my graph, and don't save. So in order to graph, we go into graph mode, but I don't start typing in because that's in f of x mode, and that's a function, and circles and circles are not functions. We're not going to graph it that way. What we're going to do is we're going to go in, we have to go into a special way to graph these things. We go into menu, and graph entry or edit, and we go into that, and then we want to go into an equation. What type of equation is a circle? And when this pops up, you'll see, oops, shoot, I didn't want to see that. So let's get out. I wanted to show you, why did I do that? So we go into graph mode. We got to go into menu. We're going to go graph an entry, and we're going to go graph an equation. And then we come over here and we don't want line, parabola, we want to do a circle. When you do that, there's going to come up two forms, the center radius form or the standard form. I thought I called this the standard form. No, this is center radius form. Center radius form is normally what this one's called, and the standard form. So let's do the standard form first. Notice it's ax squared plus ay squared plus bx plus cy plus the constant equals 0. So let's go back. It's a is 1, so I put a 1 in there. And notice that it automatically changed this one to a 1 because those have to be the same. Otherwise, it's a ellipse, and we don't want to graph an ellipse. The number in front of the x term is negative 4. These can be different. The number in front of the y was a positive 6. And my constant was 4. And if I graph this, it should graph me a nice little circle centered at 2, 3 with a radius, 2, negative 3 with a radius of 3. And there it is. Okay, now I want to do the same thing. We're going to go menu, graph entry, equation, circle, but this time we're going to use the center radius form. And if you remember correctly, it was x minus 2, so we're going to put a 2 there. And then it was y plus 3. Now, the only way to get a plus 3 in here is to put a negative 3 in there. See, it's negative, negative, which makes a plus. And we said the radius was 3, center radius form. It should overlay right on top of it. Now, you got to watch it. All right, I'm going to count to 3, and I'm going to click on it. It'll make it thick, and then it'll make it thin, right? It's going to go right over the top of it and should turn it to, I think, red. So it made it thick, And then we go. And went out right on top. So those are, in fact, the same. So let's go, and we're going to do the same thing here. We're going to try this one. So let's close out. Don't save. So we go into graph mode. We go to menu, graph entry, equation, circle, and we're going to do this weird form first. So what's the number in front of A? These are ones. Then we're going to go over here, and we put in a 2 and a negative 8. A 2 and a negative 8. And the constant was a 1. And we hit center. And there's that one. Now, didn't we say that the center was negative 1, 4? Negative 1, 4, and there it is. And it looks like I got a radius of 4. But just to see it, we go to menu, graph entry, equation, circle, and we're going to do center radius form. And center radius was x plus 1, and only we get a plus 1, you got to do a minus 1 here. And minus 4, that was the part of the equation, and we said the radius was 4. Hit enter, and there it overlaid right on top of it. So, and you can see now we've got it in center radius form, that'll be in red, and we've got it, you can't see the equation, in blue. So let's do it one more time. We're going to do it one more time for this equation. Here we go. Let's go into, all right. Oh. Didn't like me there for a second. So we're going to type in this original. So ones and ones. So get out, don't save. We go into menu. Oh, no, we got to go graph mode. Menu, graph entry. We're going to do an equation. We're going to do a circle, and we're going to do a standard form. These are going to always be ones for circles. They just always are. Negative 2 and positive 4. So negative 2, positive 4, and the constant at the end was a 1 again. 1, and we graph it, and there it is. Looks like I've got a radius of... Oh, look, I made a mistake here. See, the radius is 2. Let me show you what would happen if I made this mistake. So we go to menu, graph entry, we go equation, we go circle, and we go in this form. And if I put it in, let's see, minus 1, so no, that's minus 1. And then it was plus 2, and the only way to get plus 2 is to put a negative 2 in there. And if I thought this was a 4, you're going to say, oh, wait a second, that's twice as big. What did I do? Hit the tab button, hit the up arrow button, and said, oh, yeah, this shouldn't be a 4. This should be a 2. And there it is. It's right on top. And then that made more sense. So my radius here should have been a 2. That found my mistake. All right, kids, completing a square with writing equations in vertex form and circles. Not that bad. Not that bad. I hope you enjoyed it. That's it. Hit the subscribe button if you liked what you saw. If you didn't like what you saw, hit the subscribe button anyway. I don't care. Just because I'm ugly doesn't mean you have to freaking like make fun of me or anything. All right, boys and girls, peace out.